Good morning, good afternoon, good evening, wherever you are in the world. My name is Jeremy Rossbeck, and once again, this is the NetOps Expert. As usual, my partner in crime has joined me again, Alec Pinkham. He is the Director of Marketing for the AppNeta solution, an integral part of our network observability practice and solution here at Broadcom. Alec, say hi to everyone.
Hi, good to be here again, and happy to talk about the kind of the next step for the maturity model stuff that we've been diving into.
Yeah, this is going to be a lot of fun. So if you didn't listen to part one, check out the podcast on, I think we called it how to build a mature network observability practice, something like that. Something about right. NetOps maturity part one. This is part two, where we're actually going to compare what we wrote together in our white paper that I know in part one had in the show notes where you could download that. But an industry analyst out there read the white paper that we wrote and wrote his opinion about what he thought our maturity model looks like, yay or nay. And I have a copy of it. I'm looking at it now. It's not final, but by the time this podcast airs, you guys will be able to download it as well. That IT analyst was Seamus McGillicuddy from Enterprise Management Associate. He is the vice president at Enterprise Management Associates, and he delves into everything networking, whether it's on-prem, off-prem, AI-driven, you name it. Seamus knows everything about what makes our networks run today and what's going to make them run successfully in the future. So we thank him for his contribution here. So why don't we kick it off? Seamus took a look at what we wrote. Alec, we're just going to pull a couple bullet points out of here and talk about, really grade ourselves about what Seamus thinks about what a maturity model looks like against what we believe customers should be addressing as they mature their practice. I'm going to take a bullet point from one of his paper that's coming out soon. 72%, he said, through his research, seek tighter integration into their tools. Orgs with tight integration across tools tell Seamus that they have more success with NetOps. So what data points did we uncover in our own research, and what's in our maturity model white paper that corresponds to that? Does it agree? Does it disagree?
Yeah, obviously we have a slightly different data set, but I think, we've talked about it a lot on this podcast and personally is, the effectiveness of network operations is often dependent on their ability to access and analyze the relevant data that they have. And, with him saying that, you said 76%.
72% seek tighter integration in their tools.
Yeah. So while he's saying 72% say tighter integration, we have a stat around 24% of respondents say that they have actual immediate access to the data that they need. And I think that's an interesting thing. 76%, in a kind of a similar world, say that they don't have immediate access to the data. We're talking a lot about unification, tighter integration of tools, but the other component of that is that if you have this integration, do you also have the data that you need? And so I think we end up talking about the right data, right? The right metrics and what you're correlating, but that analysis piece is really key. And so if you have the tighter integration, right, is that bringing it into a model that you can then analyze the data quicker, more effectively? Or, is that actually just adding to your lake or your pile and actually making it harder and harder to find that needle? You've got your larger haystack, but not a better tool at finding the needle. So I think that's an interesting point. And while we don't have the exact, connection, I think the connection from our data of the lack of immediate access is an interesting one.
Yeah. And what I liked about what you said, especially the 76% that don't have immediate access, that they're not getting the access because either they have too many tools to go to, that swivel chair monitoring we talk about, which is not immediate access, or they don't have access at all to a certain tool that's looking at a certain part of the network or a certain part of traffic. Or, and we're going to get into it, as we're all relying more on public internets and cloud, who the hell is a network god of Verizon Fios? I mean, I don't know anyone that is. And if you are, God love you, but give us all access to the data you're collecting, please. And that's what we're talking about here when it comes to a maturity model.
Well, I think with the maturity model, right, we're also kind of talking about the architecture of these monitoring systems, which is basically that integration that Seamus is talking about, right? Even with tighter integration, you still may have data silos, or you may have, correlations that aren't made, connections. And I think we'll likely get into it later, but that's one of the ways that AI can help us, right? Is the higher level pattern matching, the higher level correlation and connection, that's something that's a really interesting trend is to, once we have all this data, what do we do with it? How do we make it readable for a human, and how do we make it how do we make it quicker to access?
Yeah, I'm glad you brought that up because collecting the data is one thing, but you definitely don't want 1,000 needles that you got to look through. In our maturity model white paper, and I know Seamus agrees, that once you collect the data, you have to normalize it because you're collecting data from this vendor and that vendor and that vendor, and they all speak their different languages. So how do you get all that data to speak the same language and surface that information as a global view of your network operations minus whatever vendor technology you're relying on or public ISPs or cloud that you're relying on? And that's where we help get our customers ready for AI ready networks. That means we have to do a lot of the work in the customer ecosystem of network observability before we can even rely on AI to find those patterns and those anomalies. So yeah, we don't need to offer up 1,000, 10,000 needles for our AI engine to do all the crunching. It's not able to do that yet. A network observability practice, a mature one, needs to do a lot of the data crunching so it can then elevate that information to an AI engine that can just quickly and easily look for anomalies or patterns, or take the data that we've given it and enrich a ticket or roll back a config. I just want to make sure everyone understands that your ecosystem of your network observability solution is still extremely important if you're even considering any type of AI ready network operation.
Yeah, and part of that track that you just kind of hit on reminds me that there's another statistic that connects to this a little bit. Is we had 84% of network operations teams regularly learn about issues from their users instead of their monitoring tools. And so I think that's a really good thread to pull on because it's kind of a stark disconnect between the monitoring tools that we have in place and then the actual user experience, right? And that might be one where AI can surface it quicker or better to connect the dots, right? To say, hey, we're having some application issues that is coming from our synthetic transaction monitoring that says, hey, this region is having a problem. And we connect that to potentially some changes in a core switch, or maybe we connect that to ISP information or even application servers in a private cloud environment, right? We can connect those dots to say that, hey, this device seems to be slow, or this, virtual area seems to be slow, right? That is causing bad end user experience. And that's going to bridge the gap between, a network engineer, maybe a L1 NOC person saying like, oh, this device is slow, but it doesn't look like to be a problem, right? We can connect and correlate and say, well, it is a problem because that's actually an application that's typically accessed in the middle of the day. We're about to have 100 users log in and boom, now we have a bunch of tickets that came in because people complained it was slow, right? We can get that kind of connection out and say, hey, now we're not learning about it from the users, we're learning about it beforehand. And that's something I've always said is like, it builds credibility when you send out that email before someone complains or before anyone is really, at the frustrated level and say, hey, we're aware of an issue and we're working on it, right? Just to get ahead of it.
We obviously, Holy Grail is one of them, is obviously learning about issues before users tell us about it. But like we mentioned, the prolific use of public ISP networks and cloud provider networks are here to stay. Another data point that Seamus brought up in his review of our maturity model is that more than 71% say cloud provider VPC flow logs are more important than ever. So we're going to get into cloud provider networks and what we can get from them. But Alec, real quick, why do you think 71% say that VPC flow logs are so important from cloud providers?
Honestly, I think it's been a black box for a while now. For a long time, flow logs were either difficult to get from cloud providers or non-existent, depending on the provider. So the fact that we're able to get them now and also bring them into systems that we already have, right? And we see this with our customers as well, right? That's one of the things we're working on with the VCF side of the house is making sure that we can kind of communicate and bring data together because, if you have a large, either private or, hybrid scenario for cloud, right? That's a whole component of your network that you didn't have flow visibility. And we talk about it a lot. There's a ton of ways to get metrics today. We talk about, specifically, I talk about end to end all the time. But at the end of the day, oftentimes network engineers and teams want to see the flows. They want to see that kind of atomic level unit, whether or not it's, packets directly or summarization flows, things like that, because that's the truth on the network. That's the real traffic on the network. And that tells you a lot, even if you're getting just general overview of, port protocol matching and percentages. You're getting an idea of what traffic is on the network, and oftentimes that's one of the early troubleshooting steps, is to look at it and say, okay, we have a spike in this particular type of traffic from this particular type of user or maybe location, right? And we dive in deeper, right? It's usually one of those kind of high level items that we can look at, but it also serves as a really interesting place to go to if you get information from a dashboard and say like, oh, we've got some problems with this application. I can go look at the flow from that application server if I have it. And if that application happened to be hosted in a hybrid or a private cloud environment, you may not have had that if it was from a provider that didn't access it. So I think just the core ability to have flows across more of the network is never something we're going to be mad about. So I'm not surprised at a kind of high statistic. If anything, I'm surprised it's not higher, right? Yeah. It may just be people who don't have the cloud environments, though.
Did we have any data points in our white paper that correspond to what Seamus said around folks want more data from cloud providers besides it just being flow?
Yeah, we had one that was not surprising in its own right. 95% of our respondents didn't get enough ISP or cloud information. So specifically that cloud information, it's one of those things where it could be a number of metrics that they were looking for. It could have been virtual device statistics, right? Or hosting, but at the end of the day, oftentimes it's about the traffic. And so it's not surprising that ours kind of correlates with that, because we didn't specifically say VPC flow logs, right? We got a higher number because we're just saying like, you don't get any of the information from that. So you'd like something, you'd like more. So I think that, correlates quite nicely.
Alec, what do you recommend, and what does our maturity model recommend when it comes to the most valuable data that you can or should be getting from ISP and cloud providers when it comes to triaging an end-to-end network experience for someone?
Yeah, it's going to depend a little bit on what you're looking at from where your application's hosted, right? Are your applications hosted? Like, let's say it's a VCF environment where you have applications hosted in essentially a private cloud, right? You have some of that information already, right? You have some of the cloud information from your virtual hosts and maybe your application servers, but you likely don't have that connective tissue of the network part of that in the same dashboard correlated. You don't have that end-to-end picture, which again, I'll always talk about that's the part that can be really helpful. So when you talk about, an application that's hosted in that type of environment, what are the core metrics? It really is the age-old question of, do I have enough metrics to understand if it's an app or a network problem? Like top level, I need to start there. Is it an app or network problem? And then as I get into each one of those sides, I need to be able to break the problem down. So if it's a network issue, where is it, right? What part of the environment is it? Is it in the application service provider environment, the actual cloud environment? Or is it in a transit or ISP network, or is it at the user side, right? If it's on the application side, I want to understand if it's app server or if it's a load balancer issue or if it's actually something in the back end, right? Maybe it's an API call that responds every once in a while, but also connects to a different application server. And maybe that's the one that's struggling, right? Being able to understand kind of where the problem is. And I'll say it again, where the problem is probably the most important data. So, that's not a specific metric, right? That's probably a few different metrics, and you kind of need the whole picture there in order to really get that troubleshooting efficiency down.
So before we move to our last point, because I'm going to get on my soapbox here, can you remind folks what are the stages of our maturity model are, and just a very quick 10-second description of each, because we're going to add a new stage beyond the last one.
Yeah, so we talked about it a little last time, and I think we showed it up for anyone watching the video. But our first stage is basically a manual stage. It's kind of that stage where you're hyper reactive. You're basically pulling the data that you need as you need it. The problems of that are often that you get the data after something's happened, so you miss a lot of issues, right? You get something, if it's a spike and then it goes away, you've missed it. If a device goes down, sure, you'll find it, but it's going to be more of that, like, device-based and very reactive. Stage 2 is really more of traditional monitoring. So it's the SNMP, it's the flow, it's the, packet capture in your own system. And really both of those first two stages don't take into account anything outside of your four walls. So it really was around traditional data centers, traditional network ownership. So when we get to stage 3, we're talking about adding in the modern approach of getting end to end, right? Getting to the ISP networks, the cloud networks, getting to the outside of your local area network and including the WAN in that picture. And so we typically call that the first step towards proactive as far as stances go. 4 was around kind of next gen. It's basically the predictive, right? We're taking a lot of that data, we're putting it into either pattern matching and recognition algorithms, or we're trying to do some baselining. We're getting to the point where we can kind of see the trends before they start happening. And then that's actually where some AI starts coming in, because that's where we evolve from those initial algorithms to better and better and more correlation. And then stage 5 is really around the future of automation and how can we get to that almost panacea of automated remediation. And I know I mentioned it last time, but we understand that, we're probably not going to automate every task, and we're probably not going to have AI do every task. There's probably still going to be a human in the loop. And that's a big thing that a lot of the AI vendors will talk about, is human in the loop is kind of the way to say, hey, let AI crunch the numbers and give you a suggestion, but then we're going to have a human go look at that, correlate it, maybe agree with it or disagree with it, and then press the button. So that's kind of our 5 stages right now.
Yeah, and I love what you said about let your AI engine crunch the numbers. Where does it get the numbers? It gets it from a mature network observability solution that has a awesome way of correlating and normalizing all the data you're collecting across networks you own and do not own, across any vendor technology, whatever language it speaks, Cisco, iOS, Junos, you name it, Arista. When you feed it healthy ingredients, you come out with a wonderful dish from the recipe. And I know I've said that before, but
can
this
you tell
is
it's
the point.
Lunchtime where you are?
Exactly. And it's actually right in front of me if I lower my camera. I can't say this enough. Everyone's talking AI and we can do this. And, there's a lot of AI complementary, not even competitive, complementary solutions out there that rely solely on the customer's mature network observability ecosystem. If you're not mature in your practice of NetOps, you're going to be feeding inaccurate hallucination data, that parsed data that is missing, or if you feed it great data from the four walls of your data center, but you're not getting ISP or cloud provider and your end user experiences go mostly across ISP and cloud, your AI engine is going to spit out insanely stupid answers for you. It just is. So good data in, good results out. So that's why we just stress the importance of a mature network observability practice in order to move to an AI ready network. I've said this story before, but I know that one day we'll get there. And this use case is fabulous, but it's only going to happen when you've fed it the right ingredients. If you've fed it the right numbers, like Alec talks about. I come in, cup of coffee, level 1 knock operator, ready to start my shift. Hey, NetOps knockbot.
Where should I focus knockbot?
I know.
We got to patent that or TM it,
or come up with a new name. But I like knockbot. How about knockbot? Hey, knockbot. Just got in on my shift. Where should I focus my attention today? Because I sure as hell don't want to look through 15,000 alarms and they're all red on my big screen in front of me. Nor do I want to log into 18 different sideload tools and try to figure out where I start my day. So, hey, knockbot, which is now your new AI engine that is developing and is there for your AI ready networks. Hey, knockbot, where should I focus my attention? And it says, listen, Jeremy, overnight, we're seeing a lot of packet loss above 10%, the threshold you set from a edge router in the Azure cloud on the West Coast. And coincidentally, we have 6 new tickets from the Seattle branch office complaining of slowness in the app they're using that is hosted in Azure. I would start there. Now, maybe it's smart enough to even go, listen, I've obviously isolated that it's an edge router with this IP address in the Azure network on the West Coast as affecting the Seattle office. And I've already opened a ticket with CenturyLink. to complain that they need to fix this. Your AI knockbot is not going to fix it in a network it doesn't own, like CenturyLink, but it sure as hell will light a fire under the asses of CenturyLink to get and meet their SLAs when an outage occurs. I didn't have to look through 10,000 alarms. I didn't have to sort through 1 million events. I didn't even have to get my hands on a keyboard. I just asked, where do I focus my attention? And the only way it's going to give you an answer like that is from a mature network observability solution, feeding it the data it needs for you to be successful. Off my soapbox.
Yeah, I think that's a really good point, because we talk about data a lot, and that is part of the benefit of being Broadcom, is we have a lot of different data sources that we can compile together, and that's one of the strengths that we work on. But you're right. If you pump all that data into one place, right, you can get answers out of it. If you don't have all of that data in one place, or you don't have all the different components of the data, right, you're still going to have those black boxes, and you're still going to be hearing about things from users, because you're going to be missing key components of that network delivery path between the application server and the user. And that's true whether or not you own that application server or not, right? If it's a SaaS app that your company relies on, then you better be monitoring out to it to understand whether or not that's, if it's a load balanced app or, geo-replicated, right? Which endpoint are you actually hitting, right? If you're going to open a ticket and you say, I have a problem, but you don't specify, I have a problem from Seattle over this ISP, right? You're not giving enough information for anyone else to solve it. And so you're not going to be able to solve it either. So I think that's an interesting thing. You mentioned, the AI engine opening a ticket, right? It can also provide the contextual data to say, this is where I'm monitoring from, and this is where the problem is. I can also tell you the problem is not over here, right? Because if I tell an application provider that I've got a problem, right, the first thing they're going to ask is, where are you? How are you accessing the system? It might even down to, are you using Chrome or Safari, right? But providing all those details is going to get you way closer to a solution, right? It's the same way a user sends a ticket into IT and says, hey, I've got a problem, right? That's not helpful. We need the data. We need to know, what are you connecting from? Beyond the, have you restarted lately, right? What are you connecting from? Where are you? What ISP are you over? All that kind of stuff is the stuff the system can provide for us. And I think that's where you get to resolution faster, right? It's taking the data and putting it in a consumable format for whoever the audience is. And in this case, the audience is a third party or IT, right?
Oh my God, dying to talk. Thank you. What a great point that we can round out this podcast on, because Alec mentioned many wonderful things, but one is one of the base use cases that AI can help any network operations teams today with. And it's a low hanging fruit. It's an easy one to get started because you're not going to boil the ocean, which is alarm enrichment, right? Or event enrichment. When an alarm comes in, you need to know everything about what it's saying to you so you have minimal breadcrumbs to find the root cause. And if your AI engine is collecting enough data from your network observability solution that it then passes that enriched data over to the ISP provider, they're going to obviously want to pass the buck right away. Well, did you do this? Where are you actually? Did you reboot? All those questions. But if you have the data there saying, this is the IP address of your device that is breaching 10% packet loss, and it's now at 27%, affecting this region where that router is. There's no way in hell they can pass the buck. They know they need to find the root cause within their network. Now, listen, a mature network observability solution like we talk about, that's one of the greatest things you can have, because not only do you have one source of truth, you have one throat to choke, which could be you if it's in your network, but still, at least you have the ability to find the root cause quickly and easily, and maybe before anyone wants to choke your throat. But the NetOps innocence you can uncover in minutes, if not seconds, that it's not me, it's them. Fabulous. I think we should end on that. Anything else to say?
Good. No, I end on that, nice hit, and then, close this out and be like, and tune in next time. No.
And I'm leaving all this in. By the way, Alec mentioned lunch. I have a piece of salmon in front of me that is wafting up my nose. If there was smell-o-vision, you would not be tuning into this podcast at the moment. So we're going to sign off and I'm going to finish this. But Alec, I so enjoy always having this back and forth with you. You are definitely my best NetOps expert internally in our family that I always love to share the spotlight with. Nothing against any other NetOps expert out there that we've had on our guests or on our show, but within this family, always love talking about this stuff with you. So I appreciate all your insights and valuable data points that you bring to the show. As I said, look in the show notes for the Seamus McGillicuddy EMA industry analyst white paper and how he views our maturity model, the Broadcom network observability maturity model, to get you to AI ready networks and get your knockbot answering the questions you need to answer correctly, finding your innocence, and before the user, complains. I mean, that's really some of the holy grail. So appreciate you checking out part 2 of this podcast on network observability maturity. And as always, have a wonderful rest of your week. We will see you next time on the NetOps Expert.